Hi, my name is Abinesh Pillai under MURUGESH matrix number CN200126. So today I'll be presenting my assignment 2 for Industrial Revolution. So I am from group 2. So for my group, we have chosen review of Industrial Revolution research in upper limb rehabilitation system. So this is me, Abinesh Pillai MURUGESH. This is my matrix number. My group mate is one ASFA, AQIL bin one MUSTAPA, Muhammad AMIRUL, AFIQ bin BERAHIM, and also PAAVENTHAN KUMARARAJA. So we are for Department of Electrical Engineering Technology, Faculty of Engineering Technology, University of Malaysia, Malaysia. So the abstract is modern technology has been improving as in medical technology. Rehabilitation medicine has evolved and expanded throughout time. The use of rehab robot to restore upper extremity motor function in upper limb patients has also become a major academic study topic. This has prompted research to investigate the use of robotic device to perform stroke rehabilitation therapy. This study examines the most recent advancement in upper limb exoskeleton robots for the rehabilitation of individuals with upper limb. To begin, a basic overview of robots will be provided along with samples of existing commercial devices. The achievements in upper limb exoskeleton technology are outlined as well as the basic hurdles in building this device. Future research direction are also mentioned. So this is our introduction. Numerous factors affect functional outcome of the stroke. Many studies have been conducted on upper limb rehabilitation using the facilitation strategy, which includes intensified physical therapy, electrical stimulation, and passive manipulation. So there are also a variety of factors influence function outcome following a stroke. Many studies have been conducted on upper limb rehabilitation using the facilitation strategy, which includes intensified physical therapy, electrical stimulation, and also passive manipulation. So by assisting traditional therapy, this approach can increase the patient's motor function, reduce the rehabilitation period, and also give objective parameter for patient evaluation. So in general, mechatronic and robotic system for neuro rehabilitation can be generally used to record information about the motor performance and also provoke passive movements or trigger voluntary movement of the patient whose limb is physically attached to the rehabilitation device. So it is important to note that the ability to analyze the patient performance in a repeatable and objective manner is critical in order to design a custom-built and successful rehabilitation approach, and various mechatronic devices has been shown to be highly valuable in this area. So the purpose of this study was to see if it was possible to characterize the pace of progress and maybe underline the mechanism in order to adopt targeted rehab treatments using simple need assessment metrics obtained by robot devices. So next, this review will be explained by my groupmate. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. I will continue this presentation about literature review. So in this chapter, overview of upper limb rehabilitation system forearm, upper arm and forearm function assessment and the development of technology will be discussed in this chapter. So forearm, we read the paper from Pinhas Bentry and Zauma 2050. He developed a sensing and force feedback exoskeleton safe robotic glove, which was a new haptic device that is designed to gather kinetic and force grasping movement. So this is the safe glove prototype. It has the battery, actuator, 6 actuator, actuating cable, encode, and PCB link. So the next paper is Hong Kai Yap, Andrew Moore James 2006. He developed the design of a wearable feedback system based on force myography (FMG) for user intent detection during hand rehabilitation with a soft robotic glove. So this is the FMG Velcro strap and sensor placement. It use the FSR sensor to detecting the movement. And furthermore, Solimeter, Hashir Zaid Sheikh, Muhammad Farid Malik, Farhad Raumachin, and Alison Bell 2020 designed a grip style measuring system using FSR and flex sensor using SVM algorithm to evaluate the condition of the hand. This is use the placement of FSR sensor placement. This for figure 2.2.5 leg sensor replacement on the hand. So we also have Bouncing Lin, Aijun Lin and Jian Luan Chen 2020 developed a sensorized glove that is built and uses 9-axis in inertial measurement IMUS and force sensing resistor FSR to monitor the force at the finger grip and the kinetic of the hand at the same time. This is the architecture of the proposed sensory glove. These are the prototype of 9-axis sensory glove. So for section of upper arm, we have Florin Seren from Technology University Faculty of Electrical Engineering. He used the MATLAB modeling of upper limb muscle supposed to be driven by means of FES, functional electrical simulation. This is the hybrid FES exoskeleton. So for section of forearm, we read the paper from Yamik Mangkukia from Department of Computer Engineering. He make the project electromyography EMG sensor control access orthotic robotic arm for forearm movement. This is for electrode placement for signal acquisition. We have electrode placement to place elbow movement and waist movement. We also have a reference electrode. So the last one is wearable technology in stroke rehabilitation. This is to improve the diagnosis and treatment of upper limb motor impairment. Developed and studied so that the patient can be objectively examined, monitored with wearable technology both side and outside of clinical setting. He used IMU sensor, orange, use the track of movement. That's all for literature review.
Hello, Doctor. I'm PAAVENTHAN Raja, metric CN 200-179. So I'll moving on with literature gap 3.3, game technologies to improve upper limb rehabilitation. So visual reality post-stroke upper limb assessment using Unreal Engine 4 is a study that presents an evaluation of performance based on feedback of 40 human subject and visual reality upper limb assessment method. So 20 healthy and then 20 stroke patients are introduced. So this study is done because the long time consumed of conventional rehabilitation and the mood change of the humans of the patients. So another study would be rehabilitation of upper arm early after stroke, video games versus conventional rehabilitation. So this study compares video games and conventional rehabilitation back to back. So we think the development of robots in game hybrid will improve upper limb rehabilitation tremendously. The features of games will improve the mood, excitement, and time consumption of patients, whereas robot will help better mobility and guided movements for patients. So the conclusion would be upper limb rehabilitation is proposed, studied, and analyzed based on the literature presented as reference. The study was examined to most recent advancements in upper limb rehabilitation for individual for upper limb. So there are also limitations that is discussed in literature gap and then future improvement ideas is also proposed. So we think that the game and hybrid control robot hybrid IMU sensors, electromagnetic sensors, and VR-based treatment should be researched and studied more so as They seems to be the innovation of upper-limb rehabilitation systems. And then Mendeley, this is my Mendeley login ID and then password. And these are the references used in this paper. All right, that is from me. That is all from me. Thank you.